This is the video for lesson 2, where we're going to learn about another measure of variability called the standard deviation of a data set. One thing I want to point out to you is when we're talking about variability, how spread out our data is. If we are working with the median, the measure of variability that is most closely related to the median is the interquartile range, called the IQR. If we are working with the mean, and we're going to talk about how we figure out which one to use or which one's a better representation, the measure of variability that's most closely associated with the mean is called standard deviation. And again, that's what this video will teach you a little bit about. Our learning targets, we're going to learn a new way to represent data, which is called a box and whisker plot. We're going to learn how to use the calculator to find the standard deviation of a data set. And I want you to understand how standard deviation relates to other measures, that should say measures, of variability that we have studied, okay? So let's start to take a look at this. At the top, it says statistics contains tools to answer questions that involve variability. Remember, statistical questions are questions that don't have just one answer. We would need to gather a bunch of data and then interpret the data to be able to answer the question. We want to be able to quantify. This means like we want to be able to give a number, a measure of that variability. Okay, so we want to be able to quantify how much variability exists in a data set. How different are the values from each other? Two statistical measures that we've already seen are range and interquartile range. We're going to take a look at standard deviation. Exercise 1, a marketing company is trying to determine if there is a difference in the age of people who drink 2 different sodas. They take a random sample. That just means they gather data from 15 people who like each soda and record their ages. The ages for both are shown below. Use your calculator to help find the 5-number summary for both samples. So your 5-number summary is your minimum, your maximum, first quartile, median, and third quartile. So I went ahead and entered the data into my calculator for soda A and soda B. I scrolled up to the top and I was able to type A in the top just so that I knew that that was soda A. I now want to calculate or use my calculator to get this 5-number summary. So I'm going to click menu. I'm choosing statistics, stat calculations, and I'm choosing one variable stats. Now, even though there's 2 lists in there, I'm not using both lists. I'm calculating the 5-number summary for each list separately. So I'm going to leave this at 1. The first list I'm calculating it for is A. Ignore the frequency list. That just means that each of those numbers represents 1 data point. And then my first result column, it's going to put it in column B. So let's see what this looks like. And they're wondering if A is a column reference or a variable reference. It is a column reference. So I would click OK. Ooh, so wait, let me try this again. Menu, statistics. I don't want to overwrite what I have in there. I would like to change this. I would like it to appear in column C. That was what I needed to do. So now I'll click OK, OK, and now I see my 1 variable stats. So I'm going to go ahead and scroll down. There's my minimum, 16. There's Q1 is 18. My median is 25. My maximum, oh no, Q3 is 36. Oops. Make sure you put these in the right spot. And then the maximum is 44. I think the way they've laid that out is a little confusing. Okay. Once I record that, I'm going to click Control escape to undo that. And now I'm going to do the same thing for column B. So I'm going to go menu, and hopefully this goes a little smoother this time. Stats, stat calculations, one variable statistics, one column. The X list I want to choose is actually B. And then where do I want the results to go? I would like them to go into C. So I'll click OK. OK. And here they are. Okay, so my minimum for soda B is 18. Quartile 1 is 19. That's already interesting. They're close together. Median is 23. Maximum is 30. Third quartile is 27. Now it says draw a box plot below for the two data sets. Here's how you draw a box plot. We're going to draw one of the box plots towards the top of this section and the second one right underneath it. So the first one we'll do is soda A. The minimum is 16. So I'm going to come over here to 16. I'm going to put a dot. The first quartile is 18. I'm going to put a dot there. The median is 25. Put a dot there. Third quartile is 36. I'll put a dot there. And the maximum is 44. I'll put a dot there. It's called a box and whisker plot because the two outside dots get connected with whiskers. And then in between your quartiles, you draw a box. And then at your median, you draw a line. So there's my box and whisker plot for soda A. Let's do the box and whisker plot for soda B. So the minimum is 18. First quartile is 19. My median is 23. My third quartile is 27. Oops, that's 28. And again, you're just approximating this, so I know it's not perfect. And the maximum is 30. So we'll go ahead and connect the outside two dots with whiskers. Draw a box around the quartiles and a line to represent the median. So there's soda B. So we can see from this box and whisker plot that the data is very different for these two sodas, okay? One appears to be enjoyed by a larger range of people, while another one seems to be enjoyed more by younger people. So maybe B is like a Monster drink or something like that. And maybe A is like a Celsius. I think a lot more people like a Celsius drink of all different ages than a Monster drink. I could be totally wrong, but there's an example, okay? What is the interquartile range for each sample? You must memorize, you do not get this, that the interquartile range is Q3 minus Q1. So in keeping with our color coding here, for soda A, Q3 was, I'm going to go back up here, 36. Q1 was 18. And then for soda B, your interquartile range would be, again, Q3 minus Q1, so 27 minus 19. This one I feel a little more confident doing in my head right now, 27 minus 19. So 27 minus 20 would be 7, 8. So this one has an interquartile range of 8. 36 minus 20 would be 16, 17, 18. So there's our two interquartile ranges. Make a statement comparing the ages of people who prefer each soda. Include both the comparison of the medians of the groups and the variability. So when I look at this, which soda has a higher median? Soda A. So the median age of people who drink soda A is higher than the median age of people who drink soda B. Okay. But soda A is enjoyed by a broader range of people. So here's what I wrote. I said the median age of those who prefer soda A is 2 years higher than that for soda B. There is much greater variability in the ages of those who prefer soda A as well. Its interquartile range, which is 18, is over twice as large as that for soda B. And this tells me there's a greater range of typical values. Again, interquartile range describes typical values for soda A than for soda B. So interquartile range gives us an excellent tool to qualify variation. Another tool that's been developed is called standard deviation. The formula for calculating standard deviation goes well beyond what we're going to do in this course. We're going to use our calculator to help us find this. So given the two samples we've been working with, use your calculator to find the sample standard deviation. There's a sample standard deviation, a population standard deviation. I think that's what the other one is called. You don't need to know the difference between them. What you need to know is that if they ask you in Algebra 1 about a standard deviation, they're looking for S sub X. And in your calculator, you will find that right, it says SX, okay? So for soda B, the standard deviation, it says rounded to the nearest tenth would be 4.1. Now, we don't know what that means. We'll talk about it in just a minute. I'm going to hit Control Undo, and then I'm going to calculate my stats for column A, and I want to put that results in column C. And my standard deviation is right here. It's 9.1. Oh, let me keep it color-coded. So which one had a bigger interquartile range? Soda A. It also is a bigger standard deviation, okay? The interquartile range for soda A was 18. The standard deviation, we'll call the SD, is 9.1. The interquartile range for soda B was 8. The standard deviation is 4. How do these compare? Well, the standard deviation is about half of the interquartile range. If you take 8 and divide it in half, you would get 4. If you take 18 and divide it in half, you would get 9. So these are both describing variability. The meaning of standard deviation. Standard deviation measures the variability within a data set and roughly gives us an average distance that a data point is away from the mean of the data set. Remember, the mean is this X bar. So it's telling you how far away from the average most of your data is, okay? So it says, according to your answers from exercise 2, in which of the two data sets is there a greater diversity of ages? Whoops, I want to delete this. So I typed this ahead of time. Soda A has a greater diversity in the ages because the standard deviation, again, we want to talk about the standard deviation this time, is more than twice that of soda B. So very, very similar explanation, except we're comparing a different measure. So let's talk about what the standard deviation is, okay? So it says most data within a set falls within what's called one standard deviation of the mean. So it says find the mean for each of the data sets, round to the nearest tenth, okay? So this is soda A up here. My mean is 26.7 if I round it to the nearest tenth. So my mean for soda A is 26.7. And I'm going to go ahead, I'm going to hit Control Undo, and I'm going to calculate the statistics for soda B. So I got to change my list here. I would like to store it in column C. It is a column reference, and my average for soda B is 23.4. Okay, now that doesn't tell me anything about the variability in the ages. The mean just tells me that on average, the average consumer of soda B is younger than the average consumer of soda A, but it doesn't give me information about the idea that there's a broader range of people that enjoy A. Okay. So it says here, construct an interval of ages for both data sets that represent all values within one standard deviation from the mean. So for soda A, whoops, let me switch my colors here. My standard deviation was 9.1. If I want to construct for soda A, a set of data or a range of values, one standard deviation from the mean, I need to talk about going one standard deviation above and one standard deviation below. I think. Let me double check this. I want to make sure I'm telling you this correctly. Yes. Okay. So one standard deviation means we would go, it could be a standard deviation above or below. So I'm going to take 26.7 plus 9.1. And that gives me my highest age, so 35.8. And then one standard deviation below, so 26.7 minus 9.1 would be 17.6. And I guess we're probably used to seeing it written this way, 17.6 to 35.8. So generally speaking, people between the ages of 17.6 to 35.8 enjoy soda A. For soda B, my standard deviation was 4.1. Okay, so one standard deviation from the mean means I have to go from my mean and go up 4.1, and then from my mean and go below. So I'm going to fix the error I had last time, 23.4 minus 4.1. So the minimum age for soda B, for the majority of soda B's drinkers, is 19.3. And then 27.5 would be the upper portion of the age. So again, we can see there's a broader range of ages that like soda A as opposed to soda B. The last piece is to see, well, what exactly does this tell us? How does this represent the spread of the data? So what they want us to do is they want us to circle all of the values that lie within one standard deviation of its mean. So for soda A, I want to circle anyone's age that falls in this range right here. So 18 is in that range. 22 is, 28 is, 18 is, 21, 38 is too high. 22 is, 29 is, 25, 44 is too high, 36 is too high, 27 is okay. For soda B, I've got to be between 19.3 and 27. So 25, 22, 18 is too low, 30 is too high, 27 falls within there, 19 is too low, 22 is in there, 28 is not, 25 is, 19's too low, 23 is in there, 29 is too high, 26 is in there, 18 is too low, and 20 is in there. So they say find the percent of each data set that falls within one standard deviation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 15 for soda A. Don't forget to multiply by 100 to get the percent. And what I get is 60. And then if I do the same thing, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I had to make that a decimal. And I got 53.3%. So when we talk about standard deviation, this tells us, again, where our typical ages are, okay? 60%, around 60% of data typically falls within one standard deviation of the mean. So because soda A's standard deviation is, so much higher than soda B's, I know that for soda A, most of my data is going to be 9 years above or 9 years below my average age of 26. For soda B, most of my data, meaning over 50% of my data, is going to be 4 years above and 4 years below my average, which is 23.4. So I can tell that my data for soda A is much more spread out. Okay, so here were our goals. Draw a box and whisker plot. We did that. Using the calculator to find the standard deviation. We did that. And understanding how standard deviation relates to the other measures of variability. The big thing is this: standard deviation measures distance from the mean. Interquartile range measures distance from the median. Okay? Okay, 2 more videos and you guys are done with the video lessons. Thanks so much.